Our planet faces a growing crisis. Climate change, driven by rising carbon emissions, threatens life on Earth. Manufacturing is a significant contributor. From raw material extraction to production, it leaves a substantial carbon footprint. The need for sustainable manufacturing is clear. We must minimize our impact on the environment. The time for action is now.
The manufacturing sector's contribution to global carbon emissions is substantial. In 2018, it accounted for 24% of global CO2 emissions. This equates to 9.8 gigatons of CO2. Emissions come from burning fossil fuels, using carbon-intensive materials like steel and cement, and deforestation for raw materials. Quantifying these emissions is crucial for effective action. The world is not on track to meet its climate goals. The manufacturing sector must reduce emissions. While the need to reduce emissions is clear, manufacturers face a complex web of challenges in managing their carbon footprint. Supply chains are often global and intricate, making it difficult to track emissions across the entire life cycle of a product. Data collection and analysis can be complex and resource-intensive, requiring specialized expertise and tools. Moreover, the lack of standardized methodologies for measuring and reporting emissions can hinder transparency and make it difficult to compare performance across companies and sectors. Overcoming these challenges requires a multi-pronged approach. Manufacturers need to invest in robust data management systems and adopt standardized methodologies for emissions accounting. Collaboration across supply chains is essential to gather accurate data and identify opportunities for reduction. Governments can play a role by providing incentives for emissions reduction and establishing clear regulatory frameworks. By addressing these challenges head-on, manufacturers can pave the way for a more sustainable future.
Powering change energy efficiency as a cornerstone of sustainable manufacturing. Energy efficiency represents a fundamental pillar in the pursuit of sustainable manufacturing. By optimizing energy consumption throughout their operations, manufacturers can significantly reduce both their environmental impact and operational costs. This can be achieved through a combination of technological upgrades, process improvements, and behavioral changes. Upgrading to energy-efficient equipment, such as high-efficiency motors and LED lighting, can yield substantial energy savings. Implementing smart manufacturing systems, which utilize sensors and data analytics to optimize processes, can further enhance energy efficiency. Additionally, fostering a culture of energy awareness among employees, encouraging simple actions like turning off lights and equipment when not in use, can contribute to a significant cumulative impact.
Closing the loop: sustainable materials and the circular economy. The materials used in manufacturing play a crucial role in determining its environmental impact. Traditional linear models of production, based on a take-make-dispose approach, are unsustainable and contribute to resource depletion and waste generation.
Embracing circular economy principles, which aim to keep materials in use for as long as possible, is essential for sustainable manufacturing. This involves shifting to sustainable material sourcing, prioritizing recycled and renewable materials whenever possible. Design for disassembly and recyclability should be incorporated into product development processes to facilitate material recovery and reuse at the end of a product's life. Implementing closed-loop manufacturing systems where waste materials are captured and reintroduced into the production process can further minimize environmental impact.
Beyond business as usual, embracing renewable energy and carbon capture. To achieve true sustainability in manufacturing, we must look beyond incremental improvements and embrace transformative technologies. Transitioning away from fossil fuels and towards renewable energy sources is paramount in decarbonizing the sector. This shift can be achieved through on-site renewable energy generation, such as solar or wind power, or by procuring renewable energy from the grid. Carbon capture, utilization, and storage, or CCUS, technologies offer another promising avenue for mitigating emissions. CCUS involves capturing CO2 emissions from industrial processes and either utilizing them for other purposes or storing them underground to prevent their release into the atmosphere. While still in its early stages of development, CCUS has the potential to play a significant role in reducing manufacturing's carbon footprint.
The importance of EAG certification. EAG certification is crucial for ensuring that manufacturing processes meet stringent environmental standards. This certification process involves a thorough assessment of a company's environmental impact, including its carbon footprint, energy usage, and waste management practices. By obtaining EAG certification, companies can demonstrate their commitment to sustainability and gain a competitive edge in the market. The process typically includes an initial audit, implementation of recommended improvements, and a final review to ensure compliance with EAG standards. This certification not only helps in reducing environmental impact, but also builds trust with consumers and stakeholders, showcasing a company's dedication to a greener future. The journey to EAG certification might seem daunting, but the benefits far outweigh the challenges. It paves the way for innovation, efficiency, and a more sustainable manufacturing industry. Ultimately, EAG certification sets a benchmark for environmental responsibility, encouraging continuous improvement and fostering a culture of sustainability within the manufacturing sector.